All right, so I'm just going to go through some Trig questions from last year's exam for semester 1. And, of course, it's a pretty good idea of what to expect on an exam 1 anyway. So first of all, sine of theta is equal to root 3 on 2. Now, you need to, when you go into exam 1, you need to walk in there and you're not going to give an exact value, so you need to use your noggin and you need to draw a triangle like so. And because it is an equilateral triangle, those angles are all going to be 60 degrees, and we're going to then cut it in half. So what I've got is I've got this. I've got a triangle which is 1, that's cut in half, that's 60 degrees, 30 degrees, half of 60, and that is 2. Now, because you remember what's on the triangle, you shouldn't have to really apply Pythagoras to realise that that's root 3. And that will give you that sine of 30 degrees is equal to 1/2, for example. And it'll say that sine of 60 is equal to root 3 on 2. And you can get all of sine, cos and tan for 30 and 60. The second thing that you need to know is that we've got an isosceles triangle. And I told you that I'm going to name my first child isosceles, whether it's a boy or girl. That's 1 and that's 1. They're both the angle of 45 degrees, though. Because we've got a right angle and we've got two angles which have to be equal, and we've only got 90 degrees left. So this was root 2, and then from that triangle you can get your exact values. Now what you need to know is the reference angle. What is the reference angle? Theta, the reference angle in the first quadrant. What is the reference angle in the first quadrant? Well, the reference angle in the first quadrant, we're looking for theta is equal to root 3 on 2. Or we're looking for theta is equal to inverse sine of root 3 on 2. What angle would that give me? Well, the angle is equal to 60 degrees. Now, as I said to you, cast, the she sleeps through class, all students take calculus. That's about all I can remember. What it means is that sine is positive in the first and the second quadrant. So theta is equal to, because we're looking in this domain of 0 to 360 degrees, theta is equal to, oh, don't you do this, 60 degrees, and the equivalent in the second quadrant. Now that angle in there to the horizontal is 60 degrees. So the angle we're looking at is this. This angle here, which is 180 minus 60, which is 120 degrees. Okay, I'm going to move on to the next one. This one's a very straightforward question because cos theta is equal to adjacent over hypotenuse. And our adjacent is 2 and our hypotenuse is x, so that's 2 over x. But that is equal to 4 over 5, and we're asking to solve for x. So what we've got to do is we've got to get x, and we've got to get it and cross multiply over here, and we get that over there. So we've got x is equal to 10 over 4, which simplifies to 5 over 2. Really basic question. Now these skills questions is really all you would expect in exam 1. Give the exact value of cos of 120 degrees. Now this is what we're going to find. First of all, what's the reference angle? What's the reference angle, Noxie? It is 60 degrees because it's 60 degrees. If I draw 120 here, so if I draw 120 here, that's 120 degrees, but I'm asked for the angle to the horizontal. So that reference angle there is 60 degrees. So our reference angle is equal to 60 degrees. But cos of 120, because of good old cast, 120 degrees is in the second quadrant. It's right here. So that is sine is positive. But the whole point of getting the reference angle is cos of 20 is equal to the negative of cos of 60 degrees, and cos of 60 degrees is 1/2. So it's, is that right? Cos of 60 is 1/2? I hope so. Yeah. Negative 1/2. That's all you've got to do. Now you get 1 mark for that, but I think sometimes this working, it may not be necessary, but I think it helps to establish what quadrant you're in and that could have easily been worth 2 marks. Tan of 225, well, what's the reference angle there? The reference angle is equal to 45 degrees, so tan of 45 degrees, and the reason why it's positive is because tan is positive in the third quadrant with a reference angle of 45. Now, tan of 45, I've drawn my triangle before. Tan of 45 is equal to opposite over adjacent. Doesn't matter which one we look at, 45. Opposite over adjacent. 1 over 1. Oh my God, that's 1. Okay? Now, so far, and that's what the sort of stuff you'd expect in your exam. Now, let's have a look at this one, bearings. And some students, when we did our little post-it note exercise, said that they didn't understand bearings. So if I start from A and go to east, if I go east 10 kilometres, okay, we're going to go east 10 kilometres, and then turn and sail on a bearing of 210 degrees, and I think maybe you main maths people in this room might have done bearings. Is that correct? No. You sure? Yeah. All right then. Now, the angle here is 180 degrees. And remember that a bearing, ladies and gentlemen, is always from true north. So I'm going to draw a little true north here. Not that I need to, just to show you. So 210 degrees means that I've got 30 degrees here. This angle in here is 30 degrees. And if I've got that angle of 30 degrees for a further 12 kilometres, so I'm going to make sure that I draw my diagram, and that is 12 kilometres. Now, to B. Now it says here, draw a labelled diagram showing the path of the ship and all the given information below. Well, to me, that's good enough. You've got 60 degrees from that. You've got what? You have to put 60 degrees. Well, that angle would be 60 degrees, wouldn't it? Okay. Now, it says here, use the cosine rule. Now, the problem is with the cosine rule, how I remember it is, what is the cosine rule? Well, I remember it as this, just the 1. I remember a squared is equal to b squared plus c squared minus 2bc cos a. Now, I only remember one of them because if I make the angle that I've been given as big A, then that means that I don't have to know 3 equations. So but the problem is with this question is what? We've been given this as point A. But the thing is, we actually used the cosine rule with this angle of 60 degrees. Now, if you use A, 60 degrees. So what I'm going to do is I'm going to redraw my triangle, and I'm going to go, I couldn't give a hoot if you call that point A. I'm going to call this angle here, I'm going to call this angle A, only because then I only have to remember one formula. So, I'm going to draw my triangle, and then my triangle is going to be like this, and it's not a right angle because so this is not a right angle, but this is 60 degrees, this is 10 kilometres, and because I've made that A, and I'm going to call this, I'm just going to go anti-clockwise, I can do that, I can call that B, and I can call that C. Now if I know the angle between two lengths, I have to use the cosine rule, because if I don't know what this length is, opposite the angle, that's going to be the big hint as to not using the sine rule. So let's draw it out. I'm now going to write down what I've got. I've got big A, the angle is equal to 60 degrees. Little a is, I wouldn't have a clue, but I've got to find that out. So that's good, because that's there. And I've got little b is equal to 10 kilometres. And you know what? I would probably be likely to give you a mark if you wrote all that stuff out and made some calculation error. So don't skip steps. And little c is equal to 12, isn't it? Because we were told that we went 12 kilometres from point A to some other point. So that's 12 kilometres. So now let's do it. A squared is what we're trying to find, is equal to b squared, which is 10. 10 squared is 100, plus c squared, 12 squared, minus 2bc. I'm just going to do that. 10 times 12 is 120, times 2 is 240. So that's 240 cos of 60 degrees. And guess what? You don't have a calculator. So you need to be able to do this without one. 10 squared is 100. 100 plus 12 squared is 144. And minus 240 times cos of 60. And if you don't go into your exam getting your cos values, you are going to struggle. Cos of 60 is what? At the back there, what's cos of 60, Liv? You can look at the triangle over there. What's cos of 60?
1 over 2.
Correct, 1 over 2. Thank you. So, a squared is equal to 244 minus 240 times a half is 120. So that's going to be 124. Now, it says here we've got to prove that it's this. Now, we've got to prove, if you go ahead and use the answer, throw it into the equation, you get no marks. Because you've got to prove it. You never use the answer. You always come to the answer when it says show that. And this is for exam 2 as well. If you're asked to show something and use the answer and plug it into a formula, you'll get no marks. All right? So, 124. Now, be careful, that's a squared. We want to say that a is equal to the square root of 124, which, given the fact we've got the answer, it's probably fair to say that 31 times 4 would be 124. Because now we could look at the answer and go, all right, well, there's a big hint. So that is equal to 31 times 4, which is equal to 2 root 31. And then I'm going to be really smart and go, as required. No, I got it. Okay? Required. That's what I would like you to do in your show that questions.
Even as required.
Yep, right, as required, because, oh my goodness, I've shown you. Oh, look at that. That's what you wanted me to show you. All right? And believe me, it's good practice for VCE exams. By the way, you don't really have to show too many things in further maths when you get to further maths, you main people. But there are some things that you do need to show. So, there you go. I'm going to stop the video there. Thank you for being really quiet and stuff.